I do for advertising.
This hangout is live.
Is it live?
That's what it says, yeah.
Okay.
Let's just see now. I don't know, is anybody else? If you can, you've got Wi-Fi and everything, but you know, it's not that much, so rather reserve it for the stream. But I don't know. Yeah, this is like it's not showing us like the main.
Don't update your phones.
Main thing. Yeah. Okay. Well, I suppose I will. I just see the top of your head.
You see the okay, so it's like somewhere else.
No, I think it's the. I don't know. I think it's a should be a hangout on air thing. That's not. That's not the camera. That's me. Opening camera, man. Downloading it. Yeah, I don't know. Every time you click anything, these cloud things when you download stuff.
So couldn't you? I can hear something.
You can hear, yeah. Who's it coming from? Oh, is it? What does it look like here? One there, look good to go.
In the corner.
In the corner.
That's too big a corner. 2 hours later.
You know what I think it might be? It might be me. Let's just go, yeah. Oops. I know what the problem is.
It's obviously a delay.
Yeah, there's a little bit. Okay. It's looking better now.
Doing well.
Okay, well, maybe we should start while troubleshoot the I don't know, we'll troubleshoot
Should I start?
Yeah, because otherwise...
Maybe I'm going to show some of the terminals, so maybe if you sit at the back, I'm not quite sure how easy it is to see the stuff. So that's up to you. Okay, so can you turn that thing off?
Yeah.
It's making you look.
Well, it's kind of it's lekker now.
It's making fun of you. Obviously, yeah.
I can turn the volume down.
You time you speak, it feels abused.
Okay, cool. We're good to go.
Okay. All right, so I'm going to talk to you about how to build clusters in Linux for the purpose of high availability using tools such as Corosync and Pacemaker. So this stuff is not really fresh in my mind because this stuff I did 2 years ago. But when Mark said, would you like to present something, I said I could present about it. So I refreshed my memory a little bit and I put together a presentation. I'm a software engineer. My name is Guillaume, by the way. I'm a sort of consultant, freelancer. I run also the Scala Jozi Group in Joburg. I used to be a Java developer, now I'm doing mostly Scala work. I work in the broadcast domain, so I work for a company based in the UK. They do software and hardware for broadcasting and post-production, so it's video editing stuff. Yeah, so 2 years ago I actually built a high availability solution for a Java app, or a bunch of Java apps that we had. So I looked at providing resilience for database as well as the application itself. So I'm not a Linux guru. I don't really compile a kernel on a regular basis. Also, I'm not a ops engineer, I'm mostly a software engineer. But the company I work for is quite small, so in a small company you have to do everything. You have to do software development, you have to learn how to deploy it, how to make it commercial ready, all those things. So I'm not an ops guy, but I've done ops. I've done some fair amounts. So why are we interested in clustering? Because things are going to fail eventually at some point. Either your software is going to bug, or the machine which is running is going to get issues, or someone pulls a code out, or power supply runs out, or XCOM is whatever. Eventually something is going to fail, and if you deploy your application to production, you need to be able to do the right thing to re-establish to make sure it's still running. That's essentially why you want to do a cluster. So the things will fail. So to read myself, you could have hardware issues, network partition. So let's say you get a distributed system and the network goes down halfway through, then this is the partition. The JVM on which you're running your software could crash, or it could be a human mistake. There's a joke that goes around that the cleaning lady needs to use the plug to plug the computer. Apparently it's true. But this is an example of human mistake that happens. What you need to be able to do is you need to be able to, in case of when a failure occurs, you need to detect it, and you need to decide what to do very quickly in order to reduce the impact on the users. But you also need to make the right decision very quickly. So, and you want all of this to be automated, and you don't really want someone to page you at 3 o'clock in the morning saying the database is down. You don't want that. You want a machine to detect the database is down, and basically switch to the second available node. So you need something which is very autonomous, which is why you need to look into high availability that you can use for the purpose of failover. So you have a master-slave setup where you have a master node. If that goes down, the slave takes over. You could have a load balancing setup where you get multiple nodes, each capable of certain requests, and you can have anything in between. It's a wide spectrum of solutions. Right. Okay. So if you read about this topic, it's actually extremely wide. So you have on different operating systems, you get loads of approaches. So certainly, if you do Windows, you get commercial solutions, which work as well as they do, but they tend to cost money. On the Linux land, you have also loads of options. So if you pick your database, for instance, MySQL has got a way of doing replications. You get you can have master replication, master slave replication. If you do application servers themselves have their own way of doing things. So you get the specific solutions. You also have the generic solutions, which is basically application agnostic. And this is what Corosync and Pacemaker is about. It's basically a application agnostic way of doing failover clustering. And the Linux toolbox I'm going to talk to you today is based on essentially 3 things. This is where pictures are neat. So at the bottom layer, you have this thing called Corosync or OpenAIS. I'm sure nowadays there is different things, but essentially what this is a messaging layer. Okay, so this is basically saying that at the moment you get your physical infrastructure or your virtual infrastructure, your machines basically, and Corosync is a way of saying, oh, those machines are available, they're up or down. And Corosync and OpenAIS, they have the notion of group membership. So let's say you get 5 machines and the network breaks halfway through. That means you get a cluster, a partition of 2 and 3. So this layer here understands what a partition is and understands how to recover from it. This is the group membership, the communication layer. The layer on top is using, that's a pacemaker, and the pacemaker is basically saying, I've got those machines available because Corosync tells me, and what I must do is I must make sure that certain software are running on certain machines according to some policies that are specified. So to give an example, if you set a master-slave database setup, then Pacemaker ensures that something called a database is running on one machine, and something called a standby database is running on a different machine. And then if the master database thing stops, then the Pacemaker knows how to start the standby. So if you want, Pacemaker is like a coordinator of software. And the other guys on top are the resource agent. So they are the bit which makes this setup very generic. So the resource agents are things that know how to manage a certain type of application. So for example, You have the resource agent for Apache, resource agent for database. You have the resource agent for what's called a floating IP address. You have a resource agent for a file system. So it's a very generic thing. It's actually very easy to write your own resource agent. So if you wanted to support a Docker container, you could do that very easily. The standard way of doing it. So this resource agent here controls the lifecycle of things. And those things can be software or also operating system resources like file system or network or devices, all of this. So is that picture clear? Yeah? Right. And yeah, in the middle, Pacemaker is based on a sort of represents the cluster setup using XML. Pacemaker uses Corosync to propagate that XML across all the nodes. So essentially, when you use Pacemaker, you use it from one node, and all the changes that you make are automatically propagated to the nodes using the mechanism provided by Corosync. Right. Okay. Yeah, to repeat what I said, we got the three layers about membership, policy, and resource agent. And Pacemaker is essentially a command line driven tool. When I used it 2 years ago, there was this thing called CRM, which stands for Cluster Resource Manager, I think. And now that CRM has been phased out in favor of something called PCS, which is another flavor of command line interface. I don't exactly know why it's been phased out. I think it's because PCS does more things out of the box. But because I wanted to do the presentation and because I had all this work done 2 years ago, I basically went back to what the state was 2 years ago. And hence I'm using CRM today. Okay. So we talked about. So when you do this when you research high availability, there are things that you need to learn that a cluster is basically essentially a bunch of resources which are exposed as if they were one thing. Quorum is if you have a machine, you must have a majority of them alive to be able to make any decision, and that's the concept of quorum. Now, what happens if something bad happens and let's say a network cable is split, and you end up with two groups of machines that can't talk to each other. And what can happen if you don't design it properly is that each group then decide to become in charge, when in fact they shouldn't. So the concept of that's essentially a split brain problem. So STONE is actually an acronym that stands for shoot the other node in the head. In other words, if you have a typical example, if you do a cluster with 2 nodes, which is not advisable, if you have 2 nodes and each node is running a database, one is the master, one is the slave. If the network goes down into the 2, each machine might think that they're in charge, and they say, "Oh no, I'm the master." When in fact they shouldn't, because you end up with your application data becoming inconsistent. Which is why you need to be very strict and say, "No, neither of you can become masters at this stage, because I can't decide. You can't decide with the majority of one is not possible." So STONE is basically a mechanism that says, because I can't decide, all those machines are going to be switched off. Pacemaker has got loads of mechanisms to implement STONE. One of them is basically saying power off and call a system update. So when you do high availability, you have to be very paranoid. You have to think about all the things that can go wrong, because eventually they will come up. But Pacemaker is quite good for giving you help. All right. So how do you configure a cluster? So what you do is there's this guide, which is it's a PDF file which shows you exactly all the steps that you go through. And this is a very good book, a very good PDF. It shows you how to build a I think it's failover Apache with the database talking to a shared file system. So it's actually quite advanced. But if you follow the steps exactly, it will tell you exactly what you do. So essentially what I did 2 years ago was I read the book. And what I had to do a few weeks ago is to read it again to prepare this presentation. Now, if you go through the guide, you will see that it's got actually a lot of setup. So you have to create users, you have to install software, you have to configure things. And if you do this by hand, because you have to do this on multiple machines, right? So if you get 3 machines, you have to do it on multiple machines. So the advice is, if you can use the configuration management tool like Chef. Now, because I'm a big fan of Ansible, that's what I did. So I use Ansible to essentially prepare all my cluster nodes. All right, so I'm gonna try to do a demo. So we have I've got 4 virtual machines on my computer. They're running CentOS. So it's all based on the private network. So on one machine, I've got the configuration management tool, the Ansible thing, that I essentially use to configure the other nodes. And I've got 3 cluster nodes, 1, 2, and 3. So what I do is I use Ansible to install all the software that I need. And in this demo, I'm going to show you a Nginx failover. So I had to install the Nginx on all those machines, and I use Ansible for that. So I use Ansible for the initial setup, and I use Pacemaker to do the autonomous management. All right. Okay. So are people familiar with Ansible or configuration management?
Yeah, configuration management, not Ansible.
Okay, so Ansible is a nice tool. It's written in Python. So if you know Chef, it does achieve a similar thing. So the idea is you basically you have a desired state of your system, and you describe it, and then you have an engine that runs to that desired state and prepare the system to match that state. Ansible is very nice because it's actually very easy to learn. I mean, you can get going in about maybe half a day. And it's very easy to write the recipes for the playbooks. So I guess I can show you. Let's see what in here. Some reason at all. Okay, so I use. You guys see this? So Ansible has got a YAML language, and what this is essentially saying is I've got this Ansible recipe playbook that will make sure that all the necessary software is installed. And what it does is going to target all the cluster nodes and make sure that the file is stopped. Make sure that Python something is installed. Make sure that Corosync is installed on all the nodes. Make sure that Pacemaker is installed on all the nodes, and also that make sure that Corosync is properly configured. So all those steps are done automatically, but those steps were explained in the PDF document I mentioned to you. So this is making sure that all the stuff is installed in the right steps. Where Ansible is very useful is when you configure Corosync, all the nodes have to talk to each other. Typically, they could use multicast UDP or unicast TP. For the purpose of the demo, multicast doesn't only work in this particular network setup, so I have to use unicast. So basically, you have to say each node has to know about the other, and that's done through a configuration file. So what's nice about Ansible is that Ansible knows about all the nodes, and I can template the configuration file so that each node is properly configured. So Ansible has got a notion of hosts. So I describe what my system looks like.
Maybe just full screen and just cutting off. I see on the sound. Yes, sorry. I think it's the resolution. It's cutting off like 192 or whatever. Or is it not? That's only a small thing. It's cutting off like one. Just. Let me check if the audio is coming through. If I turn the camera off, get better resolution on this, and then I'm going to turn the audio off as well.
Okay, so Ansible got a notion of inventory that lists all the nodes with specific roles. So I've got cluster nodes here, which are all the nodes I'm going to blast with the necessary cluster stack. And I've got another set of nodes which are going to be the same, which is a set of nodes I'm going to set up as potential web servers. Right? Essentially, I'm going to blast Nginx on all these web servers. But what's nice about this is if you want to add a fourth node, all you have to do is add the fourth node here, rerun Ansible, and what you have done is basically added another node to your cluster, and that node is ready to run Nginx. So it's a very nice way to automate things.
So you can have another node and it'll go and install software,
that's correct,
everything like that.
Yeah. But it's very easy to learn. That's the key thing about it. Okay, so so I do have paste. So I've got my cluster running now. So let me go stop this time. All right, so I've got this is the way my meeting processes. So I've got three nodes: so cluster node 1, cluster node 2, and cluster node 3. So all those nodes have been configured with Corosync and Pacemaker by Ansible. So if I do this, so this is the cluster monitor command, which shows you the state of your cluster. So it tells you that I've got 3 nodes which are online: cluster node 1, cluster node 2, and cluster node 3. And you can run that command from any of the nodes because they all talk to each other. Okay. I can show you. So let's. What else to do? So oops. So I was saying Pacemaker configuration is basically XML. What you can do is you can look at it, and so this information is similar to what I just showed you. It shows you what nodes are available, what attributes they are, and so on. Okay. What can I do? Okay, so we're gonna try to do a very basic thing, which is what's known as a floating IP address. In other words, we're gonna hide those 3 machines under one IP address, and at any point in time, this IP address will be assigned to each machine. But if that if that VM for some reason dies, then Pacemaker should basically say, "Oh, this VM has died," and move it to another node available. So the way you do a floating IP address is you have to deploy the resource agent. A few slides back, I had this idea of resource agent. So there's one resource agent that controls IP address. And resource agents are there's a namespace. This one in particular comes from the Heartbeat namespace. A Heartbeat is like a older version of high availability Linux toolsets, which came up with this idea. So what Pacemaker has done is they reuse the same thing. Alright, so if I can take that line, so what we're going to do is we're going to create a floating IP address. Oops, that's a bit long. I do that. Okay, so now if I do. So go back here, so we go back to the CRM Unity thing. You can see that now we have deployed something called cluster IP address, which is started on cluster node 1. which happens to be the one I'm looking at. So if I do, so I can start this from anywhere. So oops. So if I go here, you should see that node 1 has got an extra. Maybe not. Where's the node? But what you should be able to do is you should be able to ping it. So, ping. I can ping it and I can SSH into it. And I happen to be SSH on cluster node 1. Okay, so far so good. So we have this floating IP address which is assigned to cluster node 1. So what I can do is I can, oops. I can simulate a failure. I can ask cluster node 1 to temporarily leave the cluster. So over here, I'm now inside cluster node 1. So if I do this, I'm basically saying cluster node 1 removes itself temporarily from the cluster. And bang, if you look back here, now, so remember this was cluster 1, now it's cluster 2, because it has detected that the resource has essentially died, almost, and has to be restarted on a different machine. Okay. And now the SSH connection failed. If I go back here, now it's back to cluster 2. So the floating IP address has moved from one node to the next. Okay. Let me just rename that guy. So just as you can put a mode on standby, you can just re-enable it. So if I go back to cluster 1, like this, and now if you go back here, you can see that cluster 1 is now back online, but the floating IP address is still staying on cluster 2. Now what you can do is you can say you can have special rules that says cluster IP address must always be on cluster 1 unless something very bad happens. Or you can have rules that says the IP address must never be, or you can have collocation and all the rest of it. It's very flexible. So I've got my cluster IP address, and what I can also do, so what we just basically demonstrate is like a very simple failover, which was faked essentially. What you can also do is you can have a proactive one where, let's say you want to do management on the customer, whatever node, you can move the IP address forcibly to another node by using the move command. So you're essentially moving it from where it is now to cluster 3. So go back here, do that, and if you go back here, you'll see that it's moved to cluster 3. And if we go back to our SSH connection, yeah, SSH connection failed. And now it's on cluster 3. It's all working now. So yeah, so if you proactively want to move things around, that's how you do it. So typically, if you have so I mean, the example shows you with an IP address, but if you have a database or an app server, let's say you get a database running and you want to do maintenance on the actual physical machine, you can trigger a failover to another node and take the other machine offline and do some maintenance and bring it back on. Now, so once you're done with things, so let's say you want to remove the cluster IP address, you have to stop it first, and then you delete it from the cluster. So stopping it. So stopping you can do from any node. You stop it. Let's have a look. It disappeared. It sort of disappeared here, but it still is in the configuration file. So what you have to do next is you then you delete it, and then it goes away from your configuration. What you want to do. Yes, that was the the most basic cluster you can think of. Any questions? Eight. So okay, let's. So now what you can do is typing is not much fun. So to automate this, what you can do is you can define sort of snippets of clusters, and you save them in a file. And what you can do is you can import the snippets into your cluster. So the command you do is you basically update the configuration of the cluster by taking a file which contains primitive definitions. So this becomes very useful if you do anything more complicated than what we just did, because those rules can become quite complicated. So the idea is you basically group all those rules together in one file, and let's say this would be how you deploy a app server with an IP address, and then you import that file. So what I've done, because Ansible is again very useful, is with Ansible, on one machine I had pre-configured snippets, which I use Ansible to distribute to other nodes. So if you go in here, if you look in here, I put them here. So those examples here, they all came from the Ansible machine. And the one we just did is this one, which is essentially the same text but in a reusable form. And then what you do is you can do this. So it's like a shell script to facilitate how you build the cluster. Right. So we're going to be using this later. So right, done that. Okay, so the next thing we're going to do is similar to the first example. Is we want Nginx running, but we want to do it as a failover mode. In other words, at any point in time, there's only one Nginx running, and if that Nginx dies, then Pacemaker should realize that it's dead and start a new one on a different machine. Now, this is a bit different from the first example, because now we have two resources. One is the IP address. So we use a floating IP address to identify the master Nginx if you want. So Nginx will be accessed from the outside by its master IP address. So now we have the resources are, we have Nginx, we have the IP address, and the requirements that they always stick together. They're always on the same machine. This is the idea of being bound together. So this example is not really realistic because I'm going to be starting the Nginx, but actually they don't share storage at all. It's just a simplification. Right, so what do we do? Okay, so this is what the Pacemaker configuration looks like. So we're going to deploy a speaker. I'll actually show you to you on the screen. Alright. I don't know if it's more readable. Okay, so the line at the top is defining the resource that manages Nginx. And LSB means that it's going to simply use the standard script. What LSB stands for, the /etc/init.d script. So it's basically going to say I've got to have that service running, and the process is going to be monitored every 10 seconds. Now the second primitive is the IP address itself. So this is very similar to what we just did before. So I've defined the IP address, which is 105. But the difference now is that I group Nginx and its IP address together, and I form a new group called failover Nginx. Now remember, this works because Nginx has been installed on all the machines by Nginx. Right, so what we do is we just do install failover Nginx, and boom, what happened? Where's my minutes? Now, what happened is, by magic, we now have the Nginx process running on cluster node 1, the Nginx IP also on cluster node 1, because they are bound to each other. And if I do kernel space, it's coming. No. Here we go. So we got this same way. All right. Okay. So obviously, we can do similar things to last time. So we do this guy just to show you. We do from here. So do that. Now what happens is the whole thing is moved to the 2. Put it back on. Let's forget the command. Let's put it back on. Okay. Right. Now, in theory, so what I'm going to do is I'm going to start the CRM on here. And I'm just going to try to, this is what you can do. So now I'm on cluster node 2, which is where Edge is running. So if I do this, I'm going to stop it, manually stop it. Okay, out of the control of Pacemaker. So I stop it. It's just running here. What happens? Stopped. There, boom.
Oh, sorry.
And what happens? So it's now it's working. Refresh. Ooh. Nice, restarted it. Okay. It's restarted it. So it's good. Okay, so essentially Pacemaker detected that the thing was not working. So now it has to be working, so we restarted it. Now if we do something more aggressive, so if I do so it's still on node 2, I reboot, bang, and I automatically moved it to cluster node 1. Because Corosync detected that node 2 was down, and we move it to one of the other nodes.
You're going to set up there, for example, that you can say these clusters are on my web server, these clusters are on my database server, and you can say, okay, listen, if that goes down, this is where you need to jump around. Database side, this is what you need to do to jump around. So you can like set it up on one resource manager.
You can. You can do things like you can have location rules that say that 2 processes must never be in the same machine.
So it's a maybe you don't want your database to be with your load balancer. So you can express that in a rule. So like a collocation rule saying those things must never be together.
So you can have a whole cluster set up
Yeah.
with everything on it, but you can just say, listen, whatever you do, not on the same machine.
That's correct. Okay, now when we're talking, cluster node 2 came back. Let me show you something funny. So if we do, just to show you something, so I'm going to move the IP address of Nginx. Set. I forgot what it's called. So the IP address is called Nginx IP. So currently, Nginx IP is on node 1. So what I can do is IP on node 3. So what happens is Pacemaker knows that those two things are bound. So when one moves, the other one has to move. Now the bound itself is not symmetrical. In other words, the way I've designed it. So in other words, if you try to move Nginx, it will refuse because it says the thing that controls the location is actually the IP address. So that's just pretty how I designed it. But you can define groups where all the elements in the groups are equal. In other words, if you move Nginx, it will also move it. All right. Okay. So that was. That's roughly what you can do with it. Okay. So yeah. So I mean, you can build rules, collocation rules, affinity rules. You can also do things like you can have a resource that is deployed multiple times. So if you do a load balanced, let's say if you want to have multiple application servers, you can say I've got this one application server that must exist multiple times on different machines. Yeah, you have lots of rules. I sort of forgot all the details of all the rules, but I know that you can do lots of things with it. It's really cool. Right, let's move on. So that was the second cluster. Now, so we talked about resource agents before, and resource agents are very generic. There are a bunch of them on GitHub, so you get resource agents for load balancers, web servers. You can also use the standard Linux script format to write your own. You can manage databases, file system, etc., etc. It's actually there's quite a wide range of resource agents available, and it's actually quite easy to write your own. Okay. Now the example we just did, I was cheating a little bit because my Nginx we're not sharing storage. So if one went down, another one will come back up. It was fine because they were not serving anything, they were not serving any content. So you have to have some form of shared storage or replicated storage or anything in between. So one thing I used in production like 2 years ago is this thing called DRBD, which I'm not sure if you're familiar with. Basically, it stands for distributed replicated block device. So the way it works is, so on Linux you get the block devices and you can lay them. Okay. And what they've done is they've implemented the block device that talks to another block device over the network. So when you write on one machine, whatever you write on the machine gets replicated transparently to the other side. You can control how the replication is done. That's typically synchronous, but you can make it asynchronous as well. And you can have setup where if you write from one machine, it gets replicated to multiple machines. So it's using DRBD is a very cost-effective way of building a resilient storage using a machine.
Speed if you set mouse from one list.
Yeah, well, this is obviously bound to your network speed. So what you can do is, if you have a machine with multiple links, reserve 1 link for that traffic. But if it's 1 gig per second, it's fine. Well, it depends how much you write. Essentially, so what you do is you on one machine. So one machine at any point is the master machine, so the machine you write from, and the other machine is the slave machine, which is the machine being repeated. So at any point in time, you write on the file system. There's a cache magic there. Eventually, that makes it all the way to TCP messages, which are sent from this link to that link. Then this machine does the reverse operation. So everything that you write transparently is transferred, is replicated to the other station.
And you can have more than 2 machines, so you can have one and distribute it from different machines.
Yeah, you can have sort of.
Matters locally, if it sees obviously because it has to run to the other disk.
Yeah, so this so when you transfer, so all the things that you write are on checks. So there's an algorithm that checks that whatever you write is being read. So obviously this is meant to be synchronous, but there's a latency here. So the issues, but essentially it's a way of knowing precisely how behind this slave is. So you know exactly when it's written all the things that the master read.
And if you're speaking to multiple slaves, that doesn't know that all the slaves are written at the same time.
Details again, because they're specific, but you can read about it online. It's pretty, documentation is pretty good. Again, similar problem. Setting this up. So understanding how this works is actually very interesting. The setup is a bit involved because you have to create the block devices. So you can use virtual volumes, but it's a bit of typing involved. So again, if you can use an automation tool, that's great. Now the other configuration is at any point in time, only one machine can write, and the other ones are repeated. So using the RBD on its own is quite tricky because there's a lot of synchronization that's required. That's why people say that the RBD is best used with a clustering solution like Pacemaker. So in other words, Pacemaker understands the concept of master and slave, and Pacemaker is going to say is the thing that you use to essentially maintain this DRBD cluster. And you use this typically to implement replicated storage. So what I've done, and it's also what's explained in the PDF, is to set up a MySQL master-slave cluster using replicated storage. So it's a bit involved, it's very interesting. And once you've done it maybe 2 or 3 times, it actually makes sense. So I'm going to show you the so this is the actual Pacemaker set of primitives that you had to do to implement that. It's a bit hard to read, but what I'm defining at the top here are basically DRBD block devices. So the sort of thing that I'm doing. What I'm saying here is my block devices are defined such as there is a master block device and a slave block device. The master block device is the one you write to, the slave is the one that needs to be replicated. There's one master, there's one one master, one slave. So that's the base resource at the bottom. What you also define is a file system on top of that. So in other words, when the slave is replicating, you're commonly mount over the file system because it's in the first state. So you're not allowed to have a file system that looks like a protocols. It's only when that slave becomes a master that you can have a file system that looks like a protocol. So what this is saying is that a file system that follows the actual protocols. And the thing here is defining the IP address for the MySQL database. So at any point in time, I've got one MySQL database running, which is the master. Yes, the master that MySQL database has got an IP address. So similar setup to the one I just did with the Nginx. You have the master database, which has got an IP address attached to it, and the device. Sorry, and the file system and the device. So believe it or not, this is quite capable. So what happens if the master boot device dies, then this would basically say, okay, MySQL has to be stopped, the file system has to be mounted, and the IP address has to be moved. And on a new machine, or a slave machine, I've got to enable the file system, start MySQL, move the IP address. So it's basically do the failover like that. So it's, I know it looks a bit complicated, but once you've done it 2 or 3 times, it makes sense. Alright.
Sorry, does that also monitor how the replication is? You know?
Yeah.
When it fails over, there's kind of no, oh wait, we've missed a bunch of stuff that wasn't written.
Yeah, so you can also have safeguards where I think where if the slave was too much behind, then you don't do anything. You just stop, and you call it that way. Okay, so this is an example of MySQL using the RDB. What you can also do is you can use Pacemaker to do the traditional MySQL application using master slave, the built-in MySQL master slave setup. And it's equally easy or difficult depending on your experience, but you can do that. So it's not limited to using a block device. You can also do the traditional MySQL application with a master slave setup. And you can also do Postgres if you use it as well. All right. So those are the things I've done with Pacemaker. So I've built Jetty web servers with HA proxy, where the HA proxy load balancer was itself made resilient. I've done failover Jetty, which is very similar to the Nginx setup. And I've done a failover MySQL with the block device. The only difference is 2 years ago when this was done, we didn't use configuration management tools, so we didn't have a fairly long documentation that explains all the steps you have to go through. Okay, and now I'm actually looking at using Pacemaker for CouchDB. CouchDB works, so we're looking at managing that through Pacemaker. All right, so this topic is not very easy. You've got loads of corner cases, and yeah, you have to read the documentation a few times, and you have to be prepared for when things fail and to have a plan. And the testing is also quite fun, so you have to fail things in different ways. But I don't think there's any way around it. If you look at the commercial tools, the one that you have in Windows, they roughly work the same way, except that they give you a nice user interface. Apart from that, you still have to understand that you have database there. Your database can fail, and if it fails, then you're screwed, basically. So Pacemaker works quite well. It is very generic, so the resource agents, they can work for anything. The policy engine is quite flexible, so you can specify quite a few rules, location, co-location, number of cardinality. It's very flexible. Now,
the downside is that it's a bit of a, I guess it's very, if you're into Linux, you get CentOS there, Ubuntu there, Red Hat doing something else, and the problem I found myself in is 2 years ago it was working fine, but now when I tried to do the same thing, it wouldn't work because Pacemaker had moved on to using a slightly different version of Corosync, so I had to go back. It was a bit messy. So I think they have issues with distributions do different things. So OpenSUSE does something, Red Hat does something else. Ubuntu, yeah, it sort of works, but sometimes it doesn't. Yeah, so you get like different things to do the same thing. So Corosync is one membership layer. You got OpenAIS, which is another one. Red Hat's got CMAP, which is another one. And so it's like, yeah, and it's also quite low level compared to off-the-shelf software, but it's also free. Okay. Now, obviously, what I just said doesn't apply at all if you deploy to the cloud. If you use Amazon or anything like that, then all that rubbish is taken care of for you. But sometimes you don't have choice. Sometimes you have to manage your own servers and your own stuff. I guess nowadays people are quite excited about Docker. So if you use Docker, then look at something called Core OS or Fleet, which are ways of clustering your Docker containers. So you don't worry about your installing MySQL. You just have Docker container that contains the MySQL, and use the Core OS and the Fleet to do that for you. You also have the open source platforms like Red Hat, Shift, which they do provide some form of high availability. So yeah, I guess the world today is a bit different from what it was 2 years ago. But, it's still useful. The end.
But I think it's useful to know how this works, even if you deploy to the cloud, and even if you've got sysadmin setting this up for you and doing that black magic, it's always good to know what's happening, how you can work around it, but so you don't get a guy that tells you, oh no, the master cluster climbed up a tree and this is like, oh yes, no, okay, so I'm serious. That's very interesting, man. It's very good.
One question I have is, sorry, I was a bit operating the camera and stuff, but what I found confusing about this field was that Corosync started with Linux HA, high availability cluster, HA high availability. Then Corosync got split off, then Pacemaker, and there's no real documentation about how all these pieces fit together and which ones you can swap out. They attempt to do it, but it's very bad.
Yeah, it is very bad.
That's what I found was the biggest problem. So you didn't know, like, okay, Corosync, Pacemaker, but now you got HA, so which parts fit together?
Yeah.
And I suppose also because maybe those projects are sort of, even though they're friendly, they're sort of competing, so they don't really want to talk. Another thing, of course, is that, in my opinion, what also happens here is that Red Hat as an enterprise Linux operating system, right? They've got their own version of clustering, which is open, but only they use it because they don't want to use it because that's sort of a competitive advantage, right? So it's the same thing like with what would you call it, like Mir versus Wayland kind of thing. If the other projects control it, you don't have as much control over the direction, etc. So that's what also thinks behind it. It's sort of like there's no real ownership of these other projects. Like SUSE sort of is floating around a bit. And that's what I found. So the biggest challenge for me was all the different parts, and just to sort of get your understanding of it. So Corosync does the sort of the node membership management of the cluster, and then Pacemaker does the actual monitoring of the services and bringing services up and down.
Yeah.
And then I think last I read Pacemaker was also splitting something up because they're confusingly they use the Linux HA projects configuration file, so you sort of confused what the hell's going on there.
But the cluster from scratch guide is really good.
Is it?
And what they have different versions for different OS. So in the default one is based on Fedora, so it sort of works on CentOS.
But each so Pacemaker has got multiple versions. So depending on which version you pick, then it would work with a certain version of the layer underneath, which could be Corosync. And it would have a command line, which could be PCS or CR. So it's very fragmented. But if you start from that guy, then you can, if you follow all the steps, then you have something good. It's pretty good. But again, it's not easy stuff. It's quite tricky.
The other observation I sort of have, a lot of these services these days come with their own clustering built in. So let's say like JBoss or Tomcat, they have their own clusters. Where you can cluster them. So it's sometimes a bit of a decision. Where do you do your clustering at? What level?
Exactly.
Do you do it in this thing, or do you do it DRDB, or do you? And then you've got caches and distributed caches. So
I think it says admin, you want one clustering solution for everything that you cluster. So you don't want to sit and worry about the JBoss whilst that clustering there stepping in. It should be, your DBs, your applications, your files. Everything's going to be done in the same that you can just pick up and run and say, right, bang, this is what it is.
Yeah.
That would be my kind of thing. I think that the clustering inside the service, and that might work for us like in small place, but I think in a big setup you want standardized clustering.
Yeah, I mean,
I would agree.
let's say you look at MySQL. It's just an example. So MySQL has got this mechanism for replication. But depending on your application requirements, the replication might be okay because it's actually asynchronous. So there's a chance, however small it is, there's a chance that if something happens while you PC synchronizing, your slave database is behind the master database, and you basically lost data. But if your application is fine with that, then you're okay. But you still have to do the thing where something has to detect that the master is down, and one slave has to take over. And typically that will be the slave that is most replicated. So you still have to have that thing that decides which
That's
one
the
to take
manager.
over. So you still have to use something like Pacemaker.
This looks like an awesome one.
That's cool. I mean, there's a whole bunch as well, because there's also LD Director, I think it's called, or LV Director, which also does some similar stuff. So it's almost simpler if you just want to replicate. Let's say you got a load balancer, you got Apache that's load balancing between a couple of backend Tomcat servers. But now, obviously, Apache is a single point of failure. You can use LD Director to handle the IP switchover, and it's not as like a big cluster kind of thing as Pacemaker. So there's lots of solutions out there. There's tons of them, and some of them are. And if you just want to do you're a small company, you've got you've got 3 servers that are load balancing, and you want to just have failover for the root or your actual load balance itself. You just use LD Director, So it's it's complicated.
It is complicated. Easy to consultants to tell you. Charge you the money.
Or they go and then they buy somebody puts it in a little red box and sells it for millions, and they can do it.
Cool.
Okay, thanks very much. Sorry I and I forgot to do the introduction to this thing. Anyway, welcome to if you've got any suggestions, change things and stuff, let us know. This is also the first, well, not the first time, but the third time we're trying an live streaming, and we're trying to do things as we go. I'm not sure if this worked or not. It didn't look like it was sort of, freezing up and stuff, but I think it's the computer. I have to get a better one for next time. But thanks very much for the talk.
Thank you. Interesting to use this. So some of our components, the analysis between charging user. Obviously for Windows to it, there's really good application. I don't know if you go to I think where you're struggling is to convince the Linux machine that's a block task. That's a block down. Because you can only do DODBs on multiples. You got to do directories.
Direct what's right?
Directories and stuff like that.
Wow. DODB under directories.
You can. No, it's designed to work for the block.